Hello everyone, welcome to Oracle OSM Design Studio demo by Cellcom Solutions. Today we'll be discussing about OSM modeling and how it is done in Design Studio. So we have below agenda for today. We'll be discussing Oracle OSM Design Studio overview, then how the modeling is done, how the entities that are used are actually created, the lifecycle policies, the product to process mapping, the flows of the process, the types of tasks which are available in OSM, notifications, order and task permissions, build and deploy process, and finally the order testing. So let's get started. So Oracle OSM, uh, as we know, is an order and service management tool which is used to take an order from upstream system, interact with various external systems, finally complete the order and send back the update to the upstream system. So for this process, we need Design Studio to model how the order will process in OSM. So for that purpose, we use Oracle OSM Design Studio. The Design Studio is a plugin which is added by Oracle on top of Eclipse, which adds the uh, which adds all the modeling features that are required to develop the OSM solution. So here we are using Eclipse Pluto. So here we are using Eclipse Photon, and on top of that we have Design Studio plugin, that is 7.4.1 version. So here let us get started on how we do the modeling process. So firstly we will open our Design Studio perspective. So here is our studio project. Let us start by creating a new cartridge. So how a new cartridge is created? Firstly, we'll have to create a new project. So there are two types of projects available basically for OSM. One is composite project and one is normal project. So if we have multiple cartridges and we want to develop some dependency, in that case we'll use composite project. Since we are building a standalone project, we'll use the order and service management project for now. So let us create cartridge named broadband. Okay, so as we see, our cartridge is created here. We have various options here which we'll be discussing later. So here by default we have one data dictionary which is empty as of now. So this data dictionary, this is basically a dictionary. So this data dictionary is basically used to add the elements which we will be using further as part of our modeling. First and the foremost thing that we need is an order recognition rule. So how we, well, let us start. So let us start with the entity creation process. First and foremost thing that we need is an order recognition rule. So we'll give the name as com broadband order recognition rule. Okay. So this rule is basically used to identify the type of order that is received. Here we are just focused on broadband order as of now. But suppose we have different types of order for broadband, for VoIP, for mobile phone. So these recognition rules will determine which type of order to be created in OSM. Let us give the namespace as com order orchestration, since we'll be developing an orchestration process. So we'll first uncheck this build here, build automatically here. It otherwise it will build for creation of every entity and give build errors, since we have not built the solution completely. Okay, so this is our order recognition rule. So here what we have to do, in the input message will have a field which will receive the input. Usually this is input XML. So in our data dictionary we will create an element, we'll create a structure in actually input XML, that has to be a required field. This is our input XML. So this field, this variable will hold our input data that is received from upstream system. We have given it as an input here. Now OSM, what it will do, it will take that input and recognize the type of order, and it will, if that order is recognized, we can define a target order here. So it will create that type of order. This is just an order recognition rule. Now we'll create an order as well. Com broadband order. So now we have set this target order. If our order recognition rule is satisfied, then this type of order will get created. So here we can define our recognition rule. We can either put an XQuery file, or we can directly write the expression here only. Further to this, we have one validation rule here. So in case suppose you want some mandatory data that has to be present in the input XML, then only we'll create the order. So that rule will define here in validation rule. It will first check if that mandatory input is present. If it is present, it is fine. If not present, then immediately we'll fail that order there itself. We'll not create the order in OSM. Further to this, we have one transformation tab. Here we can set the order priority. Here we can set the order reference. That is the name that we'll be using for referring the orders in our OSM UI. And here we have an order data rule. But this order data rule, what it will do, the input XML parameters we can modify and transform into OSM specific fields. I mean, we can rename the fields, we can use the data, we can store that data in OSM, and same data we can use in a different structured manner rather than the one that is coming in input XML. Or we can use the same structure as well. This transformation is just to transform the data if we want to keep it in some other hierarchy or anyway. Okay, so here we now let us come back to our order. Now we'll open our order. So all these things, so here there is an option to create a new order, and here is the option to create an open an order if already created. Otherwise we can right click on this cartridge, go to new, and go to this order management, and here we have option to create all these entities. Other way is file, new, and here we can select the required entity creation. Otherwise we can go to other and type the entity that we want, and then we can create it. So there are multiple ways. So this is the order. I have opened it now. So this order is taking this input XML by default. So here in the order, let's go to this order details. So extends, if we have some similar type of orders which we want so that they can use the common data, So in that case we can use this extends property. Okay, so our main focus here is the entity creation part. The details we'll discuss later in the later part of the demo. So basically an order requires a life cycle policy. So we'll quickly create a life cycle policy. Dot cycle policy. Okay. Now our order will be fulfilled by a process. That process can be a static process or an orchestration process. The main functionality of that Oracle OSM does is orchestration process. So we'll go ahead and create an orchestration process. And orchestration process. Okay, so the orchestration process will have an orchestration sequence, broadband orchestration sequence. Now it should have an order item. Here is an order item selector which we will use to select the order items that are present in the input XML. Then here we have fulfillment mode expression. Here we have orchestration stages. Fulfillment, let us define fulfillment mode expression. So fulfillment mode is nothing but what we want to do with the order. So suppose we want to deliver the order. We have one fulfillment mode like this. Other fulfillment mode we can have, suppose we want to cancel the order. So here we can write the expression like from the input XML what parameter will pick to pick the particular fulfillment mode. It is a cancel order or a new connection order. So now we have orchestration stages. So orchestration can be done in various stages like function stage, system stage, granularity stage. So we can decide our different stages where we have to orchestrate the order finally. So order item properties, here we can define the properties of the order item. The order items will be nothing but the products that need to be fulfilled as part of the service activation. So here we can define various properties about the order item. The type of the product, we can define the requested delivery date for each product, and many other things are available. So as of now we'll just define product spec, which is nothing but our fulfillment pattern. So here we can have an expression for that. The property reference is fulfillment pattern mapping property. Here what we'll do, we'll map this product spec. So this product spec will in turn call our fulfillment pattern from here only. Okay. So now let us go back. Okay. So by default it has taken our order item that we have defined now. So creation task. Suppose an order has come to OSM. It needs a creation task. This creation task will have all the data that is required by the order throughout. And further during the order process, if we need some limited data, we can modify that in our task. So we'll create one creation task. Okay. So now we are done mostly till here. So now in this orchestration process, we have seen like there is a fulfillment pattern property that we have mapped. Now we'll define a fulfillment pattern. The orchestration fulfillment pattern. Okay, so here in the fulfillment pattern, what we'll do, we'll map the fulfillment mode. Okay, so this is a deliver mode, and here we have the definition of the orchestration plan. How the plan will be executed, what all will be the dependencies, which all functions will be participating. Okay, so let us call the functions, system, and granularity stages. I'll define the purpose of each of these in the later part of the session. So all these are called as order component specifications. Com broadband function. We can have various functions for different interactions, like if we want to query in UIM, so we can define a particular function, what that function will do. If we want to work with BRM, we can define a function, and as part of that function we can perform multiple tasks. Now this is com broadband function. Okay, so as you can see, I have defined three functions here. Let me define systems as well first, and then I'll explain further. System, sound system. Okay, so now let us get started. I close all these extra tabs. Okay, so we are back to our fulfillment pattern now. Now what we'll do, as part of this fulfillment pattern, whenever this it gets called, we'll define which all functions, which all systems need to participate here. So here I'm just defining BRM system and SOM order, BRM function and SOM order creation function. So I have added these functions in this fulfillment pattern. Now what it will do, we'll set the dependencies. In the dependencies, what we'll do, we'll define like firstly from order component and to order component. Firstly, my broadband VRM function should get executed, then my SOM order creation function should get executed. This is the dependency that I have defined now. Okay. So let me go back to same way we have to define multiple dependencies here. So I'm going back to this function now. So this order component executable is what is the final level of uh, what is the final level where you have to uh, orchestrate our order. So we'll uncheck this from here, from function stage, from system space stage as well, and we'll put this in granularity stage, which is usually the last stage for our orchestration. Okay, so now in the orchestration sequence, we'll go and define our orchestration stages. I have this com broadband function stage, com broadband system stage, and com broadband granularity. Okay, so this will be our sequence. Firstly function stage, firstly it will orchestrate based on the function, then it will orchestrate based on the system, and then it will finally orchestrate based on the granularity. Okay, so now what will happen further, when once our fulfillment pattern is called, it will define which all functions need to participate in that order. Then this function in turn has a base task. Base task has all the data that is required by for that function process, and it will have a process mapped. Okay, so process is nothing but finally a static process. So as when in the start we saw like we can do orchestration in this an order can be fulfilled in two ways: orchestration process and a static process. So in the static process directly we'll map a process like this only, but in the orchestration process we'll orchestrate the order items based on our requirements, and then finally each function will have a static process. Okay, com broadband brm function. Okay, so this is the process that I have mapped now here. I'll open this process. This usually takes some time. Okay, so now we'll model what all things will be carried out as part of that particular function. So this is our brm function. So here we can add new tasks. Task can be an automated task or a manual task. Create a new task. Here we'll put the name as sync customer task. So I have defined the task here. The process will start from here. It will execute the task. We can define a flow here. Okay, so the process will start from here. Then suppose if this task fails, in that case what we'll do, we'll add a manual task here. See customer fallout task. So this is a manual task here. Suppose this task is failed, in that case we'll fail the order and send it to this manual task, so that an order personnel can take appropriate action. And once the task is completed, so we'll have to define some stages here. Success status is already there. Let us define failure. Okay, So here I'll map the failure status if this task is failed, and here I'll map retry. Let me define retry here. Okay. Now if the data is corrected or any other issue is resolved, in that case we'll retry that order again. It will try to automatically interact with the external system and it will complete that task. Now this time the task gets successful. We move to our next task. We'll call it initiate billing task. Okay. Okay. So now this time, since we received a success response, this is success. And again further we can define a follow task here for this task, and then so same way we can model what all tasks, what all stages are to be executed as part of a process. And finally, and there are various options, we can add a sub process as well. In this big process we can add a sub process. So this sub process will again have the manual task and the automated task inside them. So we can add various rules, like here I can add a rule. So I can add flows from here to here and then here to here. If both are satisfied, then only I have to move ahead. Okay. We have timer delays, event delays, join, and finally, wherever we want to end, we'll put this end. So once the task is successful, it will finally end this process. So same way in our orchestration order, we will have multiple functions, and the functions will work based on the dependencies that we set here. So firstly, this BRM function will get executed once that process is completed. Then our SOM broadband, COM broadband, SOM order creation function, it will get executed. It will complete all the tasks that are present as part of that process, and then it will finally complete that function. And in turn, if all the functions are completed, our order will get completed. So these are the basic entities which are required as part of an order fulfillment process. We'll move ahead and continue with the session for other parts.